Okay, the 2018 number 3 from the AB exam, we have a function g. It is a piecewise function. It is linear to the left of 3, and it is this parabola between 3 and 6. They do tell you that g is the derivative of f. So I'm going to indicate that while this is the graph of g, this is also the graph of f prime. And I may make that note up here as well. F prime is equal to g. They give me a value of f of 1. They want to know what f of negative 5 is. So this is an initial condition. We do have the rate of change of f. So we're going to set this up. F of negative 5 is my initial condition plus, and then the antiderivative of f prime of x will give you the change. And I want to go from 1 to negative 5, and it is okay for the lower limit to be greater than the upper limit. We just have to remember that going from 1 to negative 5 is a negative direction. So area above the x-axis will now be negative. Area below the x-axis will be positive. So let's work this out. We have f of 1, which was, where to go, 3, plus, and then for these areas, from 1 to 0, that's a triangle. The base of that triangle, I'm going from right to left. So the area of that triangle, I'm going to say that the base is negative 1 because I'm going from 1 to 0, and that will account for the negative area. And then the height is 2. And then I will need to, we'll see, we have nothing from 0 to negative 1. And then from, I think I made, no, I don't know. I'll do a triangle. From negative 1 to negative 2 is another triangle. So that's going to be 1/2 the base of that triangle. I'm going from negative 1 to negative 2. That base is negative 1, and the height is negative 3. Plus, and then I have a rectangle with a base of negative from 2 to 5 will be a base of negative 3. And the height of that triangle is negative 3 as well. And I would stop there. I wouldn't do anything else because I now am down to only arithmetic, but I will simplify this for those of you who are curious. What the answer is, that'll be 3. That would be minus 2. This would be plus 3/2, plus 9. So 10 plus 3/2 is 23/2. And again, there's no need to do that because if you mess up, you take a correct answer and you hurt yourself. You lose points for that. Okay, evaluate the integral from 1 to 6 of g. So now we're looking at this actual function, so we're finding that integral. From 1 to 6, we do transition from a line to that parabola. So I'm going to have to break this up. I'm going to have to do 1 to 3 of g. And my 1 got hidden, put 1 there. And then I will need to find the area from 3 to 6 of g. And 3 to 6, we get to use this equation, 2 quantity x minus 4 squared dx. 1 to 3 of g will be an area of 4. That's just a square. This one, we will have to do the antiderivative. So I guess I'll put this in brackets so I don't get confused with that 4. Because the inside derivative is 1, I would do a u sub. This is a u sub situation where u is x minus 4, but when your derivative of the u is just 1, then you can kind of gloss over the inside and just do a power rule. So that would be 2x minus 4, and 2 plus 1 is 3, and we'll divide by that new exponent. And then we evaluate that from 3 to 6. And so that gives me 4 plus, I'll plug in 6. So that would be 2 times 2 cubed over 3 minus, plug in my 3. That'll be 2 times 3 minus 4 is negative 1 cubed over 3. And there is my answer. And I am not going to clean this one up. Moving on to part C. So we are looking from negative 5 to 6, so over the entire domain that we can see, what interval is the graph of f increasing and concave up. So again, we need to remember that this graph of g is also the graph of f prime of x. The derivative of f is g. And so if I want f to increase, you want to think we need f prime to be greater than 0. That's going to be really easy because I am looking at f prime, and this f prime is greater than 0 on any interval that this graph is above the x-axis, and that happens from 0 to 6, concave up. That's supposed to be CU. F is concave up when f double prime is greater than 0. And I want to connect this back to G. And I probably should do that up here as well. So f double prime is greater than 0. Well, if f prime is G, that means f double prime would be G prime. And so we need G prime to be greater than 0. And that's going to happen when the function G is increasing. Okay, so if G is increasing, that means G has a positive slope. That happens from -1. No, it doesn't. That happens from -2 to -1. Happens again from 0 to 1. And then it happens again from 4 to 6. And so those are the intervals where G is increasing, and we want the intersection of those. We want increasing and concave up. Therefore, F is increasing and concave up on the intervals where G is above the x-axis and increasing. So that happens right here. And to me, it's easier to get this off the graph. You can just think about the intervals I have listed in green and look for what they have in common, find their intersection. But this would happen on 0 to 1, and again, 0 to 1, union 4 to 6. There we go. So there's part C. Is that the last one? Nope, there's a D. Okay, so find the x-coordinates of inflection points of F. Okay, so inflection points of F, and remember again that F prime is G, so I am looking at the graph of F prime, and if I want inflection points, that means we need F double prime to change signs. Okay, well, remember F double prime is the same thing as G prime. If F prime is G, F double prime is G prime, so we need G prime to change signs. And connecting it back to the function G, if your derivative changes signs, that means that the function G has local extrema. And so what I'm going to do is I'm looking at this graph and I'm finding all local extrema, and I only see one. There is a local minimum at x equals 4. And so G has a local minima at x equals 4. Therefore, F has inflection points, an inflection point at x equals 4. And that would be the only one. This little plateau is not a local extrema because it happens over a prolonged interval. So an inflection point has to be at a point, not like a plateau. So don't get confused on that 1 to 3 section. We're not worried about that. Only x equals 4. And that is it for this question.